Then, hello everybody. So we want to start. So we will start, guys. Are you ready? Yes. So thank you so much. My name is Hector Lopez. We are on his friends. We are here because we want to show you one of our service that we have at the Open Telecom Cloud. And yeah, let's see who we are. So I am from the OTC, Open Telecom Cloud. I don't know if you know now something about Open Telecom Cloud. I hope, I really hope. It's another cloud, and of course, I'm senior product manager. I am responsible of 16 services from our cloud. And please present yourself.
Hello everyone, my name is Ferenc Kukucska. I've been working in the big data and AI spot for 2.5 years now as an architect and have been in the AI industry since 2017. In the past 5 years, I worked on projects like chatbot development using natural language processing techniques, intelligent search engines using university studies, smart camera system using Raspberry Pis, and a lot of interesting AI projects. Nowadays, I'm getting involved into more and more AI and DevOps projects.
So now let's move a little bit to what is Open Telecom Cloud, because I see some faces, they don't know what is this. Okay, you have to know Open Telecom Cloud is in Germany, so we have actually two regions. The one is in Germany, the other one is in the Netherlands, and third one, it's Community Cloud, it is in Switzerland. So just to have, give you some numbers, because you need to know, of course, what is this good for? So, or if we're, let's say, good enough for your cloud solutions. So in this case, we have achieved 150 millions of end users. So there's really a huge number, so that we are really pretty good in shape about our cloud services. So we offer 43 cloud services. In these 43 cloud services, they are IaaS solutions, PaaS solutions, SaaS solutions, and of course, big data and AI. That is the reason that we are here. On the other hand, so the space that we already achieved, 610 petabytes of storage. We already last year achieved 500, so now we have 610. We are still growing and growing and growing. That is also very good and nice to hear that we're growing. On the other hand, also from the CPUs of a month, 650,000, probably for you, it doesn't mean nothing. Last year, when we were here, we present 75,000 CPUs, so still also really moving in the right direction. So what make us really successful from Open Telecom Cloud and our end customers? One of the things that we usually know, we are GDPR compliance. That means really data privacy. It's really our main concern for your end customers. The second one is sovereign. Sovereign. I don't know if you already here last 2 years about sovereign. Sovereign in data, sovereign in technology, sovereign on operational point of view. This sovereign is only means we fulfill, follow laws and process from the country. So that means it's not like our cloud is just neutral or something like that. We have to really fulfill regulations. The other one is we are secure. So in this case, from security, it means it's not that we are just there and everyone can do whatever they want. No, it's not like this. Of course, from the point of view of the cloud provider, we have to fulfill also this kind of security regulations also. Last but not least, we are zero outage. That means our services are 24/7 available. So we have 99, we can promise you 99, 95 availability. And this is also a very good part that we are proud that we deliver to you as our end customer. So now, let's go back to the main point where we are here, because Open Telecom Cloud is not AI, and we offer only just AI services. Now, to be a little bit focused, we have a services. It's called Model Arts. With this Model Arts, it's AI ML service. So with this machine learning service, we offer in this 4 kind of life cycle that you need to know for your data. So the first one, it's data processing. So where you have data, you want to use it for trainings and so on. So we offer you on the data processing, you can just upload your image or your data that you need. You can create data collections, you can do data filtering, data labeling, and so on in the first stage, of course. After you have done all this big part of the data scientists that they will do in your company, then it moves for the training. So we offer you frameworks. These common frameworks you already know. And of course, we offer you for the ones built-in algorithms. These built-in algorithms, do you have only just your data? You choose which algorithms it's to your needs, and this is it. The next one is, of course, model management, because only what do you do with your data if you already trained the model, and then you cannot manage this. Also, you can you have this possibility to manage all your trained models. And last but not least, when you have everything done perfect and you achieve a really good % of accuracy, so what will be the next step? The next step is just to put it live. So the production system and your company and enterprise can still start working with model arts. Please, you're next, please.
Thank you. So what's cool about model arts is that you don't have to be an expert data scientist with long years of coding experience and after thousands of projects behind you, because there is a tool called XML where you don't have to code anything. You just import your data set, create an annotation file, and you can already start your training. In a couple of minutes or hours, depending on the size of your data set, you can immediately see how your model performs. So currently, in XML, there are 3 services available: image classification, object detection, and predictive analytics. But in the upcoming months, it will expand with sound and video analysis as well. If you have some coding experience, then I recommend you checking out the second option, case 2, because there are a lot of built-in algorithms and pre-configured hyperparameters for you. So it's the perfect choice if you just want to experiment and build a model quickly. You can choose among built-in algorithms like ResNet50, Faster RCNN, VGG16, SegNet VGG, and a lot of others. So this is between the beginner and the expert AI developer. And the third option suits you the best if you are a professional data scientist, and you can choose among AI frameworks, custom AI frameworks like TensorFlow, XGBoost, Scikit-learn, Caffe, SparkML, and a lot of others. Aside from these frameworks, you can also have the option custom container where you are the freest. So this is the most customizable one. By this one, you have the most freedom. You can enter the boot command. You can set the training parameters, hyperparameters, preprocessing methods to use. You can check this out as well, and a lot of options are available for you. In the Q&A.
The questions, please, in the QA section. So at the end, you can ask whatever you want, no problem. Just keep in mind which slide do you want to talk about this, no problem. Now, continuing with this, model arts, Lakes, see what is the application, so the application label of this. So we can just offer you model arts, so you can do labeling like image annotations, so it is also interesting. So that means you use our cloud, there's a user interface, there's user-friendly, and then you can start doing all that stuff. The second one is you can also deploy notebooks in the way that you can also create your modeling, your own trainings, and with that it is also very nice, easy to use. So you just deploy it, start working, and this is it. And the last part is just more like the production part. So you can decide if you really want to continue using the user interface of the OpenStack Cloud, or you have, in the most of the case, one exactly ready-to-use solution. It's just integrated with model arts, so that means with the REST API calls, then you just upload something, an image or something like that, and then you get the results of your deployed trained and see how this can be happen. So that means I just have a short demo how this is supposed to be in real life, because always just talking about service, but you don't see how it works. It's the same as somebody wants to sell me a car and I don't sit and drive, so it's the same case. In this case, we will see a page. In this page, it is a COVID solution that we already present in Open Infra Summit Berlin this year. And in this case, we will just upload image in this page. It is for recognition of COVID. it's already a trained model that is running behind this. And after that, we will upload three images. The first one will be a COVID. So it was not used, of course, for the train. It's a new image, and we will see the results if these trained results are really with full accuracy. The second one will be a normal from a lung patient, and the third one, it will be a lung from pneumonia. So let's start with this video. So we have this page prepared for this. This is like a real-world production, the doctor, then upload or use a file. This is the COVID file. Just upload this sent to REST API to the model arts that is really the trained models running, and then we see the production is COVID-19. That means it was exactly the accuracy with 99-60%. The second one is the normal one. You see it is normal. Also the accuracy, it's very well, so 99-80. And the third one is with pneumonia. So in this case, it is 100% sure the image that we already load from this patient upload to the model arts, the results are really good. So that means it's just an example how it could be possible to be used a trained model using our model arts. And now I hand over to you, please.
Thank you. So OTC AI image, this project started with a request from our PO that there is a huge demand for different AI environments, pre-installed AI environments, Conda environments, so the users don't have to deal with installing these libraries, Conda environments, pip environments, and different packages. So they could 100% focus on the development phase of their job. So they don't have to deal with GPU configuration, GPU support, version conflicts, matching libraries. Instead, they have all the time for the development. So that's when we created this AI image, which has these available frameworks, as you can see in the right side of the slide. So if any of you worked on this in the past, I'm sure they know what I mean when I say that you have to wait for long installation times, the GPU, matching version, conflicting versions, and so on. So this is the goal of it. So we created in ECS, which is Elastic Cloud Server. It's similar in AWS as an EC2. So basically, it's just a virtual server, a virtual machine, and now it's available, as you can see, in the EUDE, so in the European Union, Deutschland, in the German region, as you can see, and it's beta version in the Netherlands region as well. Now I will show you two videos about that. One of them will create a video in the German region, the other one in the Netherlands region. So let's see. So I will split up the whole process into 5 major parts. The first one will create an ECS, as I told you. So this is the most time-consuming part if we are clicking the things together on the GUI. But you can speed this whole process up if you use tools like Terraform. The second one is using SSH client. You can log into the VM, activate the OTC Lab environment, running the Jupyter Lab command, and you can develop your next TikTok or Facebook right away. So let me start the video. So this is the Open Telecom Cloud console. I will log in using my credentials. Here you can see all the services of Open Telecom Cloud. Now I will use the Elastic Cloud Server, the ECS, as I mentioned a couple of seconds ago. So in here, you can see a lot of blurry VMs. I will create a new one by clicking on this Create ECS Magenta button. And as you can see, we are in the EUD, so in the German region. I will select the specification, this GPU accelerated stuff, because AI loves GPU and these computations in high batches. So I think 64 CPUs and half a terabyte memory will be enough. The second option is, as you can see, this image. So this image is the most important one. We are using Ubuntu, so Ubuntu operating system, and we deploy that to the AI image. So AI image is available on Ubuntu. As you can see, AI frameworks is there. System disk is 250 gigabytes is enough because we are just using a couple of data sets. This is the networking section. So as you can see, this is needed because somehow we want to access our VM or page after we created this whole ECS. So we are specifying the VPC, the security group, the port numbers, and a lot of stuff. And we are also going to assign an Elastic IP address, a public IP, so we can access in the World Wide Web. After I created this one, we are going to give it a name, an ECS name as well. This will be ECS Jupyter Lab, because we are going to access Jupyter Lab later. And of course, I will create a keeper. So as you can see, I demonstrate all the steps that you need to create for creating an ECS VM. So it's that easy. So you don't have to be afraid feel free to try this out. As you can see, it's Keeper Jupyter Lab, and in the last row, it already appeared. I will download this Jupyter Lab because I will need it in the SSH client when I want to access that VM. And after I go back, I will refresh the keepers and select the Keeper Jupyter Lab. As you can see, I acknowledge that I obtained the private key, of course, and I will confirm all the settings. Here you can see the confirmation page, and the ECS Jupyter Lab is already there. It's creating. So as you can see, the GPU is there. So we use GPU accelerated version. And once it gets created, as you can see, it got created. We already got an IP address with the one starting with 80. So the Ubuntu is there, the AI frameworks is there. So now our next step is accessing this virtual machine. We are using MobiXterm for that. It's an SSH client, but Git Bash PuTTY is also okay. So I'm going to create a new session with copying the Elastic IP address. If you used the Ubuntu operating system in the past, you know that the username will be Ubuntu, of course. And the third option that we are going to choose is the advanced SSH settings, because we are going to use the private key that I obtained before. You know, private key is good because you know, some nasty guy mines Bitcoin on your machine. You don't want that. So your MD's training takes weeks, and you don't know why. This is why I recommend using a private key. I will browse that private key from my downloads folder, as you can see, and in a couple of seconds, I will hit the OK button, and I can access my virtual machine, and I'm inside. So once I'm inside, as you can see, Jupyter Lab is there. I will list the Conda environment. So basically, you can immediately do that with using the AI image. Conda and list, and in a couple of seconds, this is the first start. You should see all the listing AI environments that I showed you in the slide, and I will use the OTC LabEnv. As you can see, it's in there. So I activated that environment. Now it begins with the row with the OTC LabEnv, and I only need that command to run this whole Jupyter Lab with specifying the IP address and the port number, so I can later access it. I enter that command, and I will get a token. The token is useful because with using the token and of course the port number, as you can see, the token is up there. So with using these, I can access the Jupyter Lab from using my web browser. So I will copy the token and the port number. Yes, it's being copied. Okay, and the final thing I need is one new tab, and of course the IP address. So the one new tab is fine. As you can see, the port number has been pasted. Also, the token has been pasted. Now I'm copying the IP address in the beginning of the row, and I will click on enter. And as you can see, in the tab's name, Jupyter Lab is already appeared. So in a couple of seconds, we should see the Jupyter Lab logo and also our environments. Now I select no kernel because I want to show you what types of AI environments are there. So I will click on this tab, and as you can see, basically PyTorch 1.6, PyTorch 16, TensorFlow, and all the things are there that I showed you a minute ago. Now we use TensorFlow 2.7, as you can see in the right upper corner. So I will import TensorFlow as TF, so I don't have to type TensorFlow every time. And I'm printing the version. So as you can see, TensorFlow is running. Basically, it's done. It's that easy to use AI image to import TensorFlow. And now we can begin the coding. The next video demo will be this future gun. So in a couple of minutes, you will know what future gun is, but basically this serves as a bridge between the OTC AI image and the future gun, because I will show you how future gun is being installed with using AI image. So almost every step will be the same, except for the last two ones, because there I will deploy future gun. In the first one, you should watch the region. So I will not use the EUDE, but the EUNL, so the Netherlands region. So I will click on the login. So I fast forwarded the known parts a little bit for you. So as you can see, everything is the same. I will select the GPU and the AI image. Of course, the networking section is the same. Just a couple of differences between the security groups. I will give it a different name, future gun. Again, I will create a new keeper for that. And I will, of course, download that keeper. Click on Create Now. This is the confirmation page. I have the GPU accelerated AI framework, so I have everything. As you can see in a couple of minutes, ECS Future Gun is already there. It's creating. I obtained the Future Gun keeper, and I will again use MobiXterm. I have the IP address, so I will create a session. This is the same with the different keeper. I hit sudo opt upgrade and opt update because I want to have the latest greatest from everything because FutureGun needs it. As you can see, conda env list is also there. So with the exact same environments as you saw before, because FutureGun was written in PyTorch, I will use the PyTorch 1.10 environment. As you can see, it's already there, and I already pulled from my GitLab repo the FutureGun library, the FutureGun repository. So as you can see, I'm showing you the FutureGun train.py, so the train command with a couple of arguments. So I will use that exact command to show you how the training if FutureGun is going with using the AI image. I enter that command, and as you can see in a couple of seconds, basically it's epoch 1, epoch 2, so the training is progressed. So that easy it is to use FutureGun and AI image to install and deploy stuff. So FutureGun, what is FutureGun? If you remember our last year session where we presented OTC gun, you know that this was this child painting where we converted these child paintings into photorealistic images. We saw that people were really amazed and astonished by the power of this gun when seeing this and this state-of-the-art technology. So we had a discussion with my colleagues. How could we, take it a bit further, this whole FutureGun and OTC gun and gun stuff as well. And we did some investigation. So we saw that cycle GANs, C GANs, also pix-to-pix GAN and conditional GANs, and there are a lot of GANs available, but these are good for swap faces, for face staging, as you can see, to create photorealistic images from drawings, and a lot of stuff. But basically what we want to do is something groundbreaking. So the people know that this is useful and beneficial, and it's good for the humanity. So that's why we created something nature conscious. So me and my colleague, who I created with this whole FutureGun, we are both living in beautiful places in Hungary, and we want those places to remain the same, so our children and grandchildren can also enjoy the same mountains, forests, and lakes in the same state as they now render. So this is why we created FutureGun. So basically, FutureGun is showing the future. So in a 30 or 40 years, it will show you if the current climate change gets worse and worse, then what can we do? So you can have the question, how did we solve it? So we solved it using this cycle GAN. We couldn't have solved this cycle GAN with this whole FutureGun with OTC gun, with the style of OTC gun, because we don't have the desertifying image of Amsterdam, Budapest, or New York, and we wanted to keep that way. So we don't have those images to become real. So we needed something to become make it available. So that's why we choose cycle GAN. In the main idea of FutureGun, that basically it uses unpaired image-to-image translation. So you don't have to have the desertifying Chicago or London. It creates for you, because as you can see on the zebra horses, basically there is no horses. It created from the zebra. So it's good at transferring the characteristics. So you can guess how cool it would be if you have a photo and convert it into the style of Van Gogh. For example, you can see this starry dog in the left bottom slide. So this whole, transferring characteristics and image-to-image translation is really fancy stuff, because it's basically hallucinating the part of the content it creates. It's good for creating fancy clouds and this FutureGun of stuff, but for example in the medical area where you have to detect tumors and for example that kind of stuff, it can be dangerous. So you have to use it with good calibration and good care. So let me show you how this whole FutureGun works. We created a website for that, as you can see, or main slogan is Save the Nature for a Green Future, which describes well our intention with the tool FutureGun. As you can see, we created also a slider for that, and basically it will show the environment in 20 or 40 years if we do nothing. So if we scroll a bit down, you can see the online environmental forecaster, which is the main part of this whole FutureGun. So as you can see, you can drag and drop a file there, an image there, your nature image, and it will create the post-apocalyptic version of your image. If you scroll a bit down, you can see me and my colleague, my co-creator of FutureGun. So as I mentioned you earlier, we are very nature conscious, and we wanted to, transfer this nature consciousness of ours into people who don't consider protecting their environment that important like we do, but they like technology. So that's how the idea of FutureGun was born. Here you can also see some latest news regarding the Mediterranean region, desertification, the climate change, the gas house emission, and a couple of interesting studies. So let's see how this whole thing works. So I will choose a file, upload a file, and this will be that image, so that nature file, which me and Hector took when creating some kind of travel. So I will upload that file, as you can see, and in a couple of seconds, this is where the whole GON stuff is working. It created that post-apocalyptic image. So from this, as you can see in the left side of the browser, we created basically that one. So as you can see, the characteristics, the transferring characteristics work perfectly. The edges are also very good with using this cycle GON stuff. And as you can see, there is also a comparison slider where we can compare the original uploaded image, the image that the user uploaded, and our predicted image. So as you can see, the bushes, the mountains, the edges are quite good. From this grass, it created this sandy soil. So basically, that's what will happen in 30 or 40 years if we do nothing. This is why we created this whole FutureGun. And if you click on this page, you can see this video as well. This is an inactivity video that tells people how FutureGun works. The next project, the next demo, will be covering the full AI pipeline. So basically, this is an OpenStack-based model arts automation pipeline. The main idea of this whole demo pipeline to show you how model arts and works from creating a data set to deploying it as a service. So these are the main steps I will iterate through in the following minutes. So as you can see, first I will create a data set, then I will label the data set, then I will create a training job from that labeled data set. After that, I will build a model from that train job, and the last step is deploy the model as a real-time service. So let's begin. So as you can see here, this is my OpenStack script. So this does the whole stuff with the variable initializations, path definitions. So as you can see, there is this data and work path. So as you can see, these path definitions in object storage service, so in OBS, which you can see here in Open Telecom Cloud again, these data and work folders are completely empty. So I will click on them and show you. So this is our S3 style storage system. So as you can see, the data folder is empty. This is where I will store the data set, so basically the images. And the other one, the work folder, will be also empty. This will store the annotation files, the versions, dataset versions, the metadata of the labeling, and everything like that. So these two folders will contain all the necessary data for the dataset. So we are going a bit down. We can see here the labeled OpenStack commands for the label creations, for the train job creations, with all the necessary flagging commands, flags, parameters, like that. So once you could bit observe the script, I will escape from this script, and I will start the script with using the word test. So test word will be, this argument will be in the name of the service, the model, the dataset, and so on. So let's see what we got. The script has been started. So first I will show you the services, the main services of model art. So we have dataset, notebooks, training jobs, and model management. From these four, we are going to use three. So dataset, training jobs, and model management. Basically, notebooks are Jupyter notebooks that I showed you a couple of minutes ago how they work. So datasets can be found under data management. There you can see. And MA chain DS test, this is what we named in the OpenStack script. As you can see, it's already there, but the labeling progress is still at 0%. So it's now creating the labeling. We should wait a couple of seconds until the labeling is finished. So I have a look at my OpenStack script. It's already creating the labels, as you can see from the scripts. So in a couple of seconds, we should see the labels that it's 100 per 100. So all the labeled images are created. I will hit the refresh button in the right side of our browser. And as you can see, it's 100%. So all for the 100 images, it created all the labels. This is why we need this whole annotation file. So the dataset is currently being published. So this is the last step of the whole dataset creation. So in a couple of seconds, we should see that the dataset is ready, and we can step on the next part of the progress. So I will click on that, and as you can see, we have 100 labels, and there we can see the images. So basically, this task is containing 5 categories of flowers: tulip, dandelion, sunflowers, daisies, and tulips. And the whole goal of the project is to create a model where we can upload an image that our model has never seen before, and the model will say that, okay, it's a tulip, okay, it's a dandelion. So we have 100 flowers for that, and as you can see, the labels are under the flowers. So we have 5 categories, 20 images of each, altogether 5 categories of flowers. So that's all. You could see almost all the flower images. So basically, that's it. Daisies, dandelions. I go back to the dataset dashboard, and as you can see in here, we've got this input dataset path and output dataset path, this work folder and data folder that I showed you at the beginning of this whole AI pipeline presentation. So they were empty then, but they are not. So I will show you that via this storage path, as you can see in the last line. So I will copy that storage path, this test pipeline work folder. So as you can see, the work folder has subfolders. So we are sure that it's not empty anymore. So I will click to show you on the data folder to show you what it got. So it got an import folder. So these are the 5 folders, as you can see, the 5 categories. I will show you one image just to present you in what format and what files we have. We can access it via that URL. So we click on that, and as you can see, so this is a basic sunflower image that we use for the training. We will use other flowers downloaded from Google to test our model in the service deployment section. So I will also show you the work folder. It has an MHAIN-DS test, it has the annotation file, and also a V1. So this is the version 1 folder because we created it from scratch, and the manifest file. So as I told you in the beginning of the presentation, the manifest file basically containing all the metadata of the labeling. So as you can see, it contains the source, so where it is, where the file is, the usage, which is trained in our case, the creation time, the annotator's name, so who was it annotated by that image. It's in JSON format, as you can see. So it's created for all the 100 images. So we used that annotation file to make the model learn how this whole image recognition and categorization works. So we are done with the dataset parts. Let's go to the training job part. This is the second part. So as you can see, the train job is currently running. It's in progress. So this MHAIN TG test, this is what we named in the OpenStack script, and we click on it to show you what it has. So for example, as you can see, it's running, so it's finished this whole preparation. We can see the specification, so it uses CPU and GPU as well. The algorithm, which is ResNet V150, and the AI engine is TensorFlow, and we use Python for that. So we go back to the train job page. As you can see, it's run successfully. So basically, we are done with the training job part. It's that easy if you control the whole thing from a OpenStack script. The third thing is the model. So this is the third station. As you can see, the model is already done. This MHAIN MO test has been successfully created. We used a real-time service for that. So this is all very good if you have a look at the inference code deployment type, but these were all, covered in the OpenStack script. So let me show you that parameter configuration, which tells you what we have to enter as an input. It's basically an image file, as you can see, and what the output parameters look like. So it's a predicted label. So that image is a rose or a tulip or a dandelion and so on. And it also has, as you can see, a score. So how many percentage it gives to each flower types. This can be very important, because if we have a 50% of daisy and 50% of sunflower, then you should do something, for example, tune the hyperparameters or train the model again, so do that stuff. As you can see here, we have the inference code, also the TensorFlow, the Python, and a few useful information. Where is the model source code is stored, but we all know this from the OpenStack script. So the last step of this whole automated pipeline is the real-time service. As you can see, it's being deployed, so it's currently doing the deployment part. It's currently 9%. So this is the most time-consuming part next to the whole training progress. So I think that we should have a look at also this OpenStack script. So what is it output? Yes, as you can see, basically it's finished running. So you can see the training job, you can see the model creation, the dataset version creation. So all the necessary logs information are there if you are curious about something. So it's currently doing the deployment progress. So now we have a bit of time to observe that the left side of the screen, so that we have the dataset, the model management, the service management. So these are all the options that we used in the OpenStack script, with the exception that this is some colorful magenta style of GUI, while the other one, this OpenStack script, is basically black and white, but it's much faster, it's much more automatable. So I prefer that option, but you can also use this one. While I was talking, it's finished running. As you can see, it's already running this MA chain service test. So we click on that, and the prediction part comes. So this is the most exciting part, because now we are going to see how our model performs when we want to predict. So as I told you, we want to have some flowers that our model has never seen before. So that's why we will use Google to get us some flowers that were not among the training data. So one daisy, I think this will be fine. And we also want to have one tulip for the inference, just to present you that it's not overfitting and all this stuff. So the tulip is got uploaded, and we already uploaded it to the service deployment. We are going to hit on the predict button, and as you can see, it's scanning, and the predicted label is tulips with 100%, which can be understood because tulips are quite unique flower types in comparison with the other flowers. So let's see the other image, the daisy as well, which will be a bit trickier than the tulip, because if you think about it, it's very similar to sunflowers in a little bit. So as you can see, I hit on the predict button again, it's scanning. So let's see what we got for the daisies. As you can see, we got 97% for the daisy, and we got 2% for sunflowers, which can be understood because daisies has a bit of similarity with the sunflower type. So that was the Model-as automation pipeline.
Wow, that is really fast. That was really fast. I hope you really get that information, but you have to know, the most important thing is that it was Ferry, he showed you the end-to-end, so the end-to-end solutions, because only just to see only user interface is not all. You have to know, even if you are a really big developer and you want to use code and automation, then that will be exactly the way. And it is also possible, you see, it's not doubts. The other thing that we already just keep left for the last part of you, it's we fulfill a lot of issues, so it is like we are not just a cloud that just fulfill a few of them. It is really a strong cloud that we are focused more not only just on the standard ones, for focus more on the privacy, because it is also really, really important that we just support this GDPR. And from the other side, it is like if you have buffing, audits, and so on, we are also ready because we have also support in this part. That means, of course, it is not like the regulations are somewhere else. They're also just based on the BSI Foundation, or it is Federal Office of Information Security in Germany. They have this AIC4 catalog. If you don't know what is this and why it is good for, it is you have to be really aware that it is just a PDF documentation. It is 54 page that you have to read. In this 54 page, it is really decided how AI application and service has to be offered to the end customer. So that means we have to fulfill that everything from our point of view at the service level, it's fulfilled for transparency, for data privacy, to try to avoid working of the service. So we have to really be sure that the end customers knows what they're using. It is also a way that if there's something wrong, we can also prove that it's not our service that create this, and this kind of certification, it's really important. The other one is Open Telecom Cloud fulfills the C5, so this Cloud Computing Compliance Criteria Catalog. It is even worse, 132 page, but nevertheless, it is most of this. What do we expect with this AC4? So as I told you, this just we fulfill the preliminary criteria. Preliminary criteria is the C5 certification, then security, robustness, reliability, that service will be always available, and we know exactly if the service is not available, will be also really supported for you. Data quality, so we know that the data will be not lost. It can be also replicated. Explainability, every time that you move or use part of the service, you will be always aware about what you are doing. The other one is bias. Bias is really tricky because it is like for ethics point of view, we are not doing kind of manipulation. We don't support this kind of manipulation, and this is it. So we're, I think, close with the presentation. If there are some questions right now, please just raise your hands. You have one question before?
Yeah, I was thinking more or less like, is there something kind of data glossary that can be generated from the input data?
Yes, we have a microphone. Yes, sorry for that. Yes.
So I was thinking more or less like if there is a facility like a data glossary, because that's something that we are missing pre-integrated in any of the cloud, let's say AWS or Azure or Google Cloud. So data glossary is something. Is there something that in there that enables the kind of data quality check or having a business glossary or technical glossary from the data?
And so data quality check is a really big point because it is about quality of the data. So actually, we offer you this object storage, the bucket, so you can just put your data there. But definitely, at the point of the company, we expect that you, as a company, have a data scientist that can really take care about how the quality of the data should be then transferred to the cloud. Otherwise, you could upload, of course, 10,000 of tons of image, but that they are not really with high quality, and of course this will be decrease the quality of the accuracy of the model that you are training. So in such a case, then unfortunately there is not kind of this data quality assurance. So it is part of your responsibility. Our responsibility is that your data that you access are available, are reliable, are replicated, and there is no doubt that your data that you're using are the right ones. One more question, please. So since then that we are done, if you want to see or get more detail about these demos, how we do it, we have, of course, our live system on our booth on the Open Telecom Cloud. Just come away, ask the question that you see, oh, I would like to see how really you use this script, what is behind that, how we can improve such kind of possibilities to deliver to you. Just let me know. We are both there on the booth. Thank you so much.
Thank you.